15.4 Equations with Rational Expressions. In example 1, we will just be looking at the domain of the variable in each equation. So recall that the domain means the set of all possible x values for an equation. So we're going to look for all the x values that do not make the equation undefined. So in example A, we're going to look at the denominator, because the denominator, a 0 in the denominator, is the only thing that would make it undefined. So if I look at the denominator, I have x and I have 6x. So setting them equal to 0 gives me x equals 0. So the domain is going to be everything, all x's that are not 0. So we'll write that in set notation. So it's going to be all values of x such that x is not equal to 0. So this basically translates to x can be any number that's not 0. So on example B, I'm going to set x minus 5 equal to 0. So x is equal to 5, which means if I plug a 5 in here, I'm going to get 0 in the denominator. I'm going to do the same thing for the next one. X plus 5 equals 0. So x equals negative 5. So if I plugged in a negative 5, that would give me 0 for that denominator. And then on my third fraction, if I factor this, that's a difference of 2 squares. So that's x plus 5, x minus 5. And I've already set both of those equal to 0. So in this case, I have two numbers that are not part of the domain. So I'm going to write the domain in set notation. So it's all values of x such that x is not equal to negative 5 or 5. In example 2, we're actually going to start solving these equations. So to solve the equations, the first step is going to be to find the least common denominator and multiply the whole equation by that LCD. So in example 2, my denominators are 20, x, and 4x. So my LCD is going to be whatever all three of those can multiply to. In this case, they can all multiply to 20x. So that's what I'm going to multiply my whole equation by, 20x. And since I'm dealing with fractions, I'm going to write it as 20x over 1. So then I'm going to distribute that. So if I have 20x over 1 times negative 3 over 20, my 20s cancel, and I just have x times negative 3. So this is going to be negative 3x. Then I'll do the same thing with the next fraction. So I'm multiplying 20x over 1 times 2 over x. So in this case, my x's cancel, and I have 20 times 2, which is 40. And then I'll multiply by the 5 over x. So again, 20x over 1 times 5 over 4x. The x's cancel, and I can cross reduce the 4 and the 20, so that's 1 and 5, and then 5 times 5 is 25. Okay, notice on all of these I canceled out my denominator, so I don't have fractions anymore. So on step 1, when you're finding the LCD and multiplying it, the equation by the LCD, you're clearing your fractions. Alright, and then step 2 is just going to be to solve for x. Alright, so I can subtract 40 from both sides, and I have negative 3x equals negative 15. Divide by negative 3. So x equals a positive 5 because negative divided by negative is positive. Now, you're just going to want to go back and plug in your 5 and make sure that it doesn't make anything undefined. So in this case, 2 over 5 is okay, 5 over 20 is okay. So my solution is going to be x equals 5. Okay, in example 3, our first equation, we're going to start solving. Step 1 was to find the LCD and multiply it. And when we're doing step 1, we are clearing the fractions. Alright, so it starts out as a rational equation, but you're going to multiply and clear out the fraction and end up with just a simple equation. So in this case, I have x plus 1, x minus 1, and then x squared minus 1 factors to x plus 1 times x minus 1. So my LCD is going to be that product x plus 1 times x minus 1. Alright, so when I multiply by the first one, the x plus 1's will cancel, and I'm just left with 3 times x minus 1. Then when I multiply it to the second one, I still have my x plus 1 here, but my x minus 1's cancel. So I'm going to have x plus 1 times 1. And then when I multiply it by the third one, x plus 1 cancels, x minus 1 cancels, so I'm just left with the minus 2. Alright, so now step 2 is just to solve for x. Alright, so I'm going to distribute, so that's going to be 3x minus 3 equals 1x plus 1 minus 2. So equals x minus 1. So I can subtract x, and that gives me 2x, and I can add the 3 to both sides to get 2 on that side. Dividing by 2 gives me x equals 1. Alright, if I go back and plug in x equals 1, 1 plus 1 is 2, so this is going to be 3 over 2. 1 minus 1 is 0. So in this case, I cannot plug in a 1. A 1 is not part of the domain. So even though I got my solution of x equals 1, 1's not going to work. So this is going to be the empty set, or no solution, because the only possible x that I could get is going to make this undefined. So you always have to pay attention to what your domain is. You always have to go back and check your answers on these types of problems. Alright, so for example B, I'm going to factor my x squared minus 9, which would be x plus 3 times x minus 3, and my other denominators are x minus 3 and x plus 3. So my LCD is going to be that product of x plus 3 times x minus 3. So when I multiply it, my x minus 3's cancel, and I have 1 times x plus 3. And then my x plus 3's cancel, and I'm left with 1 times x minus 3. And then on the third equation, they both cancel, and so I'm just left with equals 6. Alright, so x plus 3 plus x minus 3 equals 6. So my 3's cancel because 3 minus 3 is 0, so I have 2x equals 6. Divide by 2, and x equals 3. So if I go back to plug that in and check it, 3 minus 3 is 0, and 1 over 0 is undefined. And so, again, this is the empty set because my only x is going to make it undefined. Okay, for example 4, I'm going to start off by factoring all of my denominators so that I'm able to find an LCD. Okay, so my denominators are x minus 2 times x plus 3, x plus 2 times x minus 2, x plus 2 times x plus 3. So I'm going to find my LCD. So I'm going to look for what they have in common. So I have an x minus 2. I have an x plus 3. And I have an x plus 2. So notice that even though it's repeated on 2 of them, I am only going to write it one time. Alright, so my LCD is going to be the product of all 3 of those. Okay, so when I multiply by all 3, so I'm going to multiply it on this side because I have more space. X minus 2 times x plus 3 times x plus 2. Alright, when I multiply it by the first one, the x minus 2 cancels, the x plus 3 cancels, so it's just going to be 4 times x plus 2. Multiply by the second one, I have my x plus 2, x minus 2. Those cancel, so it's just 1 times x plus 3. And then when I multiply by the third, x plus 2 and x plus 3 cancels, so it's going to be 2 times x minus 2. And then we'll distribute and just solve for x. So 4x plus 8. Make sure we distribute that negative, so negative 1x minus 3 equals 2x minus 4. 3x plus 5 equals 2x minus 4. So I get x equals negative 9. And I need to plug that in and check it. So since they're already in factored form, it would be easy to plug that in. So negative 9 minus 2 is okay. Negative 9 plus 3 is okay. Negative 9 plus 2 is okay. Negative 9 minus 2, negative 9 plus 2, negative 9 plus 3. So I'm just plugging in to make sure nothing is going to be equal to 0. So since that's not going to make any of them 0, then my solution set is just negative 9, or x equals negative 9. Example 5, solve 1 over x plus 4 plus x over x minus 4 minus 8 over x squared minus 16. So factoring the x squared minus 16 is x plus 4, x minus 4. So my common denominator is going to be x plus 4 times x minus 4. Okay, so when I multiply by the first one, the x plus 4 cancels, so I have 1 times x minus 4. Plus my x minus 4's cancel on this one, so x times x plus 4. And then they both cancel on the last one, so just negative 8. So that's going to be x minus 4 plus x squared plus 4x equals negative 8. So x squared plus 5x minus 4 equals negative 8. So since this is a quadratic, meaning it's x squared, I'm going to set it equal to 0. X squared plus 5x plus 4 equals 0. And then I'll factor that. 4 is 2 times 2, but that won't give me 5. So I'm going to do 1 times 4 to get the 5. So then x equals negative 1 and x equals negative 4. So if I plug those answers back in, then negative 4 plus 4 will give me 0, so that one won't work. But a negative 1 is okay, it's not going to make anything 0. So negative 1 is the only solution.